All right, everyone. We've got Mario from Sysinternals for Linux. If you're an old Windows user, you probably remember Sysinternals. Awesome set of tools for debugging, um, exploring your applications in your system, and Microsoft is bringing those to Linux. So, welcome, Mario. Thank you for joining us.
Awesome. Thank you, Hayden. Welcome, everyone. I guess good evening, good morning, good afternoon, wherever you may be located. My name is Mario Hewert. I'm a principal customer engineer at Microsoft, and what we'll be talking about today is Sysinternals for Linux. So let's do a little bit of a history track here. Let's talk about what Sysinternals, where it kind of came from. And Sysinternals was a tool suite that originated on Windows quite a few years back, and it's a tool suite that's been hugely popular with IT admins, developers, quality assurance engineers, etc. It's a tool suite that's got quite a few tools in them, and the best way to think about them is that they give you a very deep insight into what's happening in the system in general, like sort of like what processes are running, what are they doing, and all these kind of things. And so just to give you a few examples of what the Sysinternals suite for Windows does, or the tools that it has, is Process Explorer. It gives you a list of all the running processes on the system. May not think that that's a big deal, but it actually does allow you to go deeper into it, listing what sort of API calls it's making, what are the modules that are loaded, and even down to the call stack, right? So it's quite a useful tool. And then we got another one in the tool suite called Process Monitor. We'll talk about that in a little bit, as well as ProcDump, which we'll also talk about in a little bit. And there are many other tools in this tool suite that has really helped engineers get to the root cause of problems that might be happening in the system. So with that, we have Sysinternals for Windows, and one of the things that I was kind of thinking about several years back was, well, would it make any sense at all to move some of these things over to Linux, right? And as part of that, and as part of that research, it turns out that there are some tools that exist on Linux that we have in Sysinternals for Windows today, and there are some that don't, right? And so what we're trying to kind of establish is more like guiding principles around what do we want to do in terms of Sysinternals for Windows, in terms of moving over to Linux. And so some of the guiding principles that we have is we don't at all want to reinvent the wheel, right? If there is a tool on Linux that does it today, then we're not interested. Like, we're not going to touch that part, right? Because it already does it, and it does it well, right? The other sort of guiding principle behind this is around being production ready. Quite often in production scenarios, when a system is misbehaving, it's misbehaving to a point where things are really bad. And so we want to make sure that the tools that you run to diagnose the issue isn't going to create additional overhead and potentially not even run because it has that overhead, right? So we want to make sure that the tools are small, footprint-wise, and we want to make sure that they're targeted, and we want to make sure that they have low overhead in terms of CPU consumption and memory consumption. Another guiding principle that we established on is that we wanted to be, it was going to be born in Linux. We all know that the approach that we take sometimes on the Windows side doesn't necessarily translate well to the Linux side, right? And so if we were to take some of these tools from Sysinternals, we want to make sure that they feel sort of native, approachable, and comfortable for people that are in the Linux community. And last but not least, all of these tools that we're developing in terms of Sysinternals for Linux, they're all going to be open source. They're available on GitHub. So that's a little bit about sort of the motivation behind what we're trying to do with Sysinternals for Linux. And with that, let's take a look at a couple of the tools that we have moved over. So the first one is ProcDump for Linux. Now, ProcDump is a way to generate core dumps on Linux. And you may be like, well, we already have tools like that. You know, the canonical example being gcore. They're all sort of on-demand core dump generation, meaning that you have to sit there, and when you want to actually take core dump of the process, you have to kind of, you know, type in gcore-p and all of these things. ProcDump, the real value add for ProcDump stems from the fact that it allows you to monitor processes that are running based on certain triggers. So you can say, hey, I want you to monitor this process and generate core dump when a certain specific thing happens. So a great example of that is you might have your web app running, and sporadically, you don't know when exactly it's going to happen because it's indeterminate. CPU spikes, and it spikes for about a minute or two. And during that time, obviously, you know, if it's a credit card transactioning system, you're going to be losing money throughout that time period. And so realistically, getting a sort of sysadmin or whatever on a bridge or on a call, generating a core dump using gcore or something like on the on-demand generation tools is probably not going to be sufficient. So the real power of ProcDump is really being able to say, hey, you know what? I know that something bad is going to happen because we kind of experienced it before. And I know it's around CPU consumption. Like at some point it spikes at 90%. And so you just let ProcDump run in the background, tell it whenever CPU exceeds 90%, I want you to generate a core dump. Then you can take the core dump off of the production machines and you can debug it and get to it. One of the new things that we've done since last time at WSConf is we've integrated it with .NET Core 3.x and higher. It's not so much that we want to focus on .NET Core. It's more about proving things out a little bit. When you ask ProcDump to monitor your process, say, for example, when memory goes above a certain threshold, well, in some of these other runtimes like .NET or Java, the memory that's being consumed, oftentimes from the operating system point of view, looks a lot higher than what your actual .NET Core or Java app is using because it pre-allocates a whole bunch of memory. And so what you end up with is a core dump that's insanely big. Like it depends a little bit on your system and how much RAM you have and all that. But on my particular system, like a Hello World app will result in about a 6 gig core dump. And that becomes a little unmanageable because you got to have to transfer that off of the production machines. You got to get it back on your dev machine, and you got to go and use a debugger there. So what we've done is we've integrated it with .NET Core. And what happens is it's completely transparent to the user. ProcDump will automatically figure out that you're looking at a .NET Core process, and it will utilize the .NET Core dumping mechanisms to create a much more manageable core dump than you would otherwise get, right? So that's a new thing that we've added for ProcDump for Linux, and we're also investigating, obviously, other sort of managed runtimes outside of .NET Core. To install ProcDump for Linux is pretty straightforward. It's just sudo apt install ProcDump, and then you have the link down here. Again, this is all open source, and this is the link to the GitHub repo. So with that, let me give you just a quick demo of ProcDump. Now, one thing you'll notice is that ProcDump does require sudo. And the reason we do require sudo is in order for us to be able to interpret your triggers, whether that be CPU or memory or any of the triggers that we have, we query procfs, and so that requires sudo access. But let me just run ProcDump without any arguments at all. So that just gives you the help screen, and you'll kind of see here is that we got a few triggers. So dash capital Z, C trigger core dump generation when CPU exceeds or equals specified value. Lowercase c is when it goes below a certain value. Capital M is when it exceeds a memory value. Thread count exceeds or equals the specified value, and the same for file descriptor. And then we got a few other configuration options. I'm not going to go into those. But the point being is that you have a few triggers here that you can target for your application depending on some of the things that you're seeing that might be misbehaving. So if I wanted to create a core dump, let's say I think I got, let's see. Yeah, I got htop running in the background. So let's just say I wanted to create an core dump off of the htop process. So I can do sudo procdump. And what you have to do is you have to tell procdump what particular process that you're interested in. And you do that through a process ID, right? Every single process that launches, regardless of Linux or Windows, has a process ID attached to it. And you can find that up here through the PID column. And you'll notice that procdump runs, and it basically says it immediately generated a core dump. So this is an example of on demand, pretty much the same thing that you can do with gcore, right? But let's say that I wanted to monitor htop, and I want to say, you know what? Actually, let's use threads. So if htop ever uses 2 or more threads, I want you to generate a core dump. And it's sitting here now just monitoring, and we don't see any core dump being generated. And that's likely because, I mean, I'm guessing that htop is just kind of single threaded. We specified 2 threads, right? So I'll break out of that and I'll say, well, if htop uses 1 thread, and the core dump was generated. So all of these triggers that you see, memory, CPU, file descriptor counts, thread counts, you can use all these triggers to generate core dumps when it happens. So that's kind of the value add of ProcDump, is the monitoring aspect of it and generating core dumps when those triggers happen. All right, so the next tool, we actually just released a preview of this tool, I want to say a month or 2 months ago, and it's procmon. Essentially what procmon does is it allows you, when you run it, to get a list of all processes running on the system and all the syscalls that all of those different processes are making. And it's not just giving you the syscall like, hey, process X called poll or something like that, but it gives you far more in-depth information. So it gives you things like, when did the syscall happen? What was the result of the syscall? What were the input arguments? All the way down to what was the actual call stack. So if you're running your app and you're seeing it that is misbehaving, maybe it's just taking too long on certain requests, you could run procmon and start looking into the syscalls and see which ones are the ones that are taking the most. and that will allow you to sort of hone in on that specific part of your application. I mentioned that it does all of the processes across the system, and for each process, all the syscalls. That's a lot of data, but we do have some filtering and search capabilities included as well in procmon. So if you're interested in a particular process, you can use those filter and search capabilities. Again, just like procmon, install is trivial. Sudo apt install procmon, and you'll have that installed. So let's do a quick demo for procmon. Sudo, much like ProcDump, procmon requires sudo. One of the things that I didn't mention on the previous slide is that the technology that we use to be able to collect all this data is BPF. And at a super high level, BPF is a way to run your own code in a sandboxed environment in the kernel. And by sandbox, I mean it doesn't allow you to do anything, right? But it does allow you to collect all of this really super useful telemetry data around syscalls. And so that's what procmon uses, and it requires sudo to actually get that to work. So if I run procmon, you'll see this TUI show up, and let me just I'll suspend the collection for a bit through F5. And you'll notice that we've got the start time, when the trace was starting, and then we got the number of events that is actually being collected. And I mean, I literally just ran this for, I don't know, 2 or 3 seconds, so we're up to almost 5,500 events. And then down below here, you see all the data that's being collected, and it's kind of categorized by the columns here. Timestamp tells you an offset from the start time. The PID is the process identifier of the process making the syscall. The process itself is just the name of the process, so init, localhost, dockerd, containerd. The operation is the syscall itself. So we got things like poll, read, write. The result column shows you the result of that syscall. And then you got the duration, which tells you how long the syscall took in milliseconds. And finally, the details, which gives you the arguments that are being passed into the syscall itself. So a lot of data being shown. Now you can hit enter on any of these, and you'll get some additional information. One of the more critical ones is the stack trace down here. Now you'll notice that it says unknown. We are tracking down an issue in terms of BPF, the technology that we use to get this data, and it being namespace aware. I'm running obviously this in WSL, and WSL starts their instances of the distros in individual namespaces, and the BPF / BCC APIs aren't quite capable of understanding that. They fixed that since then, but we're working to integrate that. So once that is all done, you will see a complete call stack down here. Some of the other things that you can do is, let's say, again, these are all tracing processes from all parts of the system. We can see that here, the process name is all different. If I was interested, say, just in the init process, because that's the one that I feel is causing some problems, I can push F4, which is filter. And I can just do init. And I will get all of those entries or the events that's been collected, but only for init, right? Another really interesting feature here is the F8 or stats key. So if I hit that, what that gives you is the top 10 syscall statistics. So it gives you the top 10 syscalls. It gives you how many times they've been invoked and what the total duration of those were. Meaning that if I've honed in on a particular process in procmon and I'm perhaps seeing some slowdowns or things aren't progressing properly, this particular view can give you some syscalls that are taking the longest amount of time. And it might help you actually get to the root cause of what the problem might be in your app. The other thing that I want to mention real quick is all of this data is being stored off to disk. We use SQLite, so you can use the F6 key, which is export. And that will actually just dump a file on your local drive that has all this data in there. And it's a SQLite database file, so you can use any of the SQLite commands that you may be familiar with to do querying over that as well. All right, so that is the quick sort of introduction to procmon. Let's talk a little bit about roadmap. So for ProcDump, we're always investigating new triggers. We have there's no shortage of triggers. We have a lot of requests of adding new triggers to it. And it's just a matter of figuring out sort of, which ones are the most valuable to everyone in the community. And so we're always adding new triggers, making sure that we take community feedback into account. We want to do slightly tighter integration with .NET Core. We have .NET Core exposes counters. Like I mentioned earlier, like if you're running your Hello World .NET Core app, your app from a runtime perspective might only think that is using a little bit, but there's under the covers a lot more memory being reserved/allocated. And so it's very useful at times to basically be able to say, hey, .NET Core, can you tell me exactly how much memory you're using for my app? And so that's kind of the next integration point that we want to do. Another thing that we have heard loud and clear is adding a trigger for exception. So if an unhandled exception occurs, dump a trigger. And there are more advanced scenarios that you can do with this based on first chance exceptions, second chance exceptions, and specific type of exceptions. So we're looking into that as well, and additional runtimes like the integration we did with .NET Core. Can that make sense with other managed runtimes like Java or something different? So that's something else that we're looking into. For procmon, as I mentioned, we just released procmon preview. It is at the moment, it is Ubuntu 18.04 only. Obviously, 20.04 has been out. We are just a couple of weeks, maybe 3 weeks away from adding support for 20.04. That has to do a little bit with how BPF works, and we just have to make some adjustments. And then we also want to take it to other distros. So then kind of the next thing that we want to do is take it to Fedora and the derivative distros that might be there. Now, in terms of other new tools that we're looking at, Sysmon is one. We are looking at potentially, we're still in the sort of investigative phase of that, but there seems to be a lot of interest around doing Sysmon for Linux. So that's kind of one thing that we're looking at. And then, the other thing is really looking to the community to tell us, what other tools in this sysinternal suite that you would all love to see, right? And that's kind of one big, major driving factor behind our decisions is let's make sure we get the right stuff out that people want to see and that they want to use. And then in terms of feedback, I'm on Twitter, just at Mario Heward, and then down here are a couple of links to our GitHub repos for ProcDump and procmon. So with that was kind of a whirlwind tour of the updates for Sysinternals for Linux. Not sure if we have time for questions or not. I kind of got off to a little bit of a late start trying to get some of these things sorted out. But Hayden, do you want to take over?
Sure. I've been monitoring for questions and answering them as they come up. We've got links to the GitHub repos in the chat, and people seem to be picking it up and excited about procmon in particular.
Cool.
That is
awesome.
Great.
Yeah, no, any and all feedback that you want to give, we would love to hear it.
Cool. Well, thank you so much. We appreciate it. We love hearing from you. Question: can procmon send signals to processes?
It cannot at this point. No. That's an interesting scenario, though. Yeah, for sure. Yeah.
I think you'd heard that before.
Yeah. So we'll take that into account for sure. It's an interesting scenario.